the faces again, and all the who's new. Oh, quite a few, and all the new faces. Yeah, that's cool. What else? Yeah. Who's never been here before? We usually split it in two parts. First section is talks, and the second section is the hack and learn part. And that one is, it always depends a bit on the people. So sometimes it's a bit longer and a bit more interactive, and like people like ask you other questions. It's also more like a networking part. And for the talk part, I have to read that. We have two talks today. I think both people are from Otto. Is that correct? No, you're not from Otto. You're.
I'm from Otto, but I don't hold a talk.
No. Who? Okay.
This is Mainmatter.
Okay.
We can also
yeah.
use
Okay.
the slides.
That's good. That's good. So we have two sponsors of the talk, Mainmatter and Otto. They, I think, will also say a few words about their companies and stuff. But we have two talks. One is a blueprint for Rust and Axum apps by Marco, and the second one is an introduction to programming microcontrollers with Rust by Andreas. What else? Oh yeah, the usual disclaimers. Be nice. We follow the Rust community code of conduct. If you feel that it is not followed, talk to either any of like myself, the organizers, or any trusted person in private, or via PM or whatever, and we try to find a solution. Also, if you or your company want to organize one of these events, mostly hosting, that's always welcome. You just write me on Meetup, or if you find me anywhere else, or any of the other organizers, and yeah, just propose a time. It's usually like the evening slot. I mean, it's an evening slot during the week. I advise you to, like, Thursdays are usually quite good for meetups. Wednesdays also work. Don't pick a Friday, I guess. And then the deal is you provide the location, some food, drinks, and you may use this opportunity for advertisement for your company and hiring advertisement, etc. That's all. That's all you get. You don't get any private information, or we don't forward you any membership lists or anything. That's just the normal stuff. All right. Are there any questions at this point? No. Cool. Then I hand it over to you.
Thank you, Marco. So my name is Kai. Welcome you all here for another Rust meetup at this time at Otto in the Collaborate. At Otto probably most of you know Otto, I think. We are the second biggest e-commerce company in Germany. And we at Otto, mostly we use Java for our development. So I'm a developer here, and I have to use Java and Kotlin currently, but I'm working on it. But we also have at least one team which committed to use Rust for all of their development, and there are some minor projects here and there, and some POCs and so on. So something is growing, and I hope it's more growing in the future. Yeah, and that's basically all I want to say here. So have fun, welcome again, and I hand over to Marco.
Yeah, thanks. Thanks, Kai. So before saying more about myself, let's switch to my slides, because there I have slides about myself, obviously. So I want to talk about Blueprint for Rust backends today. Who am I? I'm Marco. I'm the founder of Mainmatter. We're organizing this today, as they already said before, with the Rust Hamburg meetup and Otto, who are so nice to host us today. Who is Mainmatter? What are we doing? We're a software engineering consultancy. We're focused on web and cloud projects, front end and back end. And we help clients to deliver better results more efficiently and more predictably, as well as to adopt new technologies, right? And one of these technologies that we help clients to adopt is Rust, obviously, right? So what we offer is, in particular around Rust, is a custom development where clients hand over work they don't want to do themselves or they can't do themselves, perhaps. We do training and support. We have a pretty extensive catalog of Rust workshops. So if you want to have a Rust workshop, then please reach out. We also do team reinforcements where our, okay, so I just realized I can't scroll my notes here. Where our experts sort of join the client's team to work with them for some time on any project that's important to the client, and that really pairs well typically with training and support, right? Do a Rust workshop first for a few days, and then our experts sort of work with the client's team after that for some time to help them sort of like put what they learned on the workshop into practice sort of in their project. And then we also do strategic advice, which includes sort of advice on like architectures and sort of like technical transformation, developer tooling process, and so on. And we also organize or like co-organize events like this, and organize a conference you might have heard about, hopefully, which is Gerust. I hope some of you were there. I know you were there, Kai. I hope some others were there as well. And I hope everybody who was not there is going to come next year, October 9 and 10 next year, and we'll be in Paris next year and online. It's a hybrid event. So you can also join remotely, but I would recommend, or like, if you can make it, then join us in Paris. It's going to be nicer. I also brought some stickers from this year out there on the table. So you see, we're quite heavily involved with Rust and the community. And that's because we believe it's great, right? As I think all of you sort of would agree with. And we think it has a lot of potential also in areas where that potential hasn't really been realized yet so much. And we're not the only ones who love Rust, obviously, right? Like all the decision makers at the big corporates love Rust no less than us. All of the big players in the industry are sort of in the process of adopting Rust in quite significant ways. So like AWS, who use it for their platform. Google is using it heavily. Microsoft is using it in Windows, I think, and so on, right? And also Rust like flies planes and satellites and so on, because it's obviously a great fit for that as well. In general, just one second, I want to see what I can figure out a way to scroll these, but no. So in general, Rust is being used everywhere where sort of previously people used C and C++, right? Like systems programming, operating systems, obviously, embedded stuff, low-level tooling, like JavaScript tooling, you might have heard, is like massively moving over to Rust games, game engines, and so on. But like I said, we are more focused on a different area, which is we are more focused on a different area, which is the web, right? So front end and back ends, Rust obviously more on the back end, and that's not really something where a lot of people used C and C++ before, obviously, right? People use like Ruby, Python, Node, Java, that kind of stuff there, right? But yet we think that Rust has a lot of potential in that area as well, because it gives teams building web and cloud apps access to capabilities that were previously out of reach, right? Like new levels of stability, new levels of performance, new levels of efficiency, and also new levels of sort of long-term maintainability, right? Which is a nightmare with like Ruby JavaScript, Python, and so on, right? And while the web and cloud space is still relatively young and an evolving area for us, still there's quite some companies that do it already to some extent, right? One of them being Otto, which is sort of its limited use, but we all hope it's going to be growing over the next years, right? But the question is, how do they do it, right? And how does a team that wants to start a backend project in Rust now, essentially, how do they go about doing that project and putting sort of the plan into reality? In general, Rust is ready for the web, right? Like web.org is not lying, right? All of the different things you need to be handled in order to build a full backend application are handled. There are crates available for all of that stuff, right? So first of all, obviously there's Tokyo, which is kind of the async runtime and really the main building block for a lot of the backend stuff in Rust. Then obviously there is the web frameworks, right? Axum, Actix being the most popular choices. And in general, everything you need to be handled is handled, right? Like HTTP in all versions, WebSockets, TLS, and so on. So if you get all of that in Rust. Then kind of below the web framework, you have databases, right? There's mature and well-maintained drivers, sort of at least for the most relevant databases. There is object relational mappers, if you want to use one. There are sort of relatively stable options there as well. And there's a number of data stores that are written in Rust themselves, obviously, because Rust is like a pretty obvious use case for those kind of things. And then there's a number of other things you want to be handled when writing a web, like serialization, deserialization, like Surday, obviously hugely popular in the Rust space. Implementations of various messaging formats and crates for like internationalization, templating, and all of that, right? But the point is, all of this is a bit of a draw the rest of the owl situation, right? So if you have all the building blocks, but you need to figure out how to put them together and how to like actually build a project that you can also maintain with a group of people, right? But ideally, we would really have something that's on a higher abstraction level, right? So that teams can be focused more on solving the essential complexity of their application versus spending time and losing time figuring out accidental complexity. Like folder structures, like setting up logging and tracing, like figuring out how to organize the data access layer, and so on, right? All of these things you don't necessarily, like if you spend time on that, that's not necessarily valuable in the sense of sort of, how it supports your business goals. There are some approaches for that. So there's Loco, there's Rocket, obviously there's Pavex as well. They are all a bit different in terms of their approaches, and we don't necessarily agree with all of the decisions they make, right? Although I have to say we agree with a lot of the stuff that's in Pavex, because that's being written by Luca Palmieri, our like principal Rust consultant and Rust expert sort of at Mainmatter. Yet it's very ambitious and new, and therefore it's not necessarily the perfect choice for everybody, right? It's certainly a great choice for some, but not necessarily for everybody, right? So we thought, let's add another option to this group here, and one that answers sort of the question of how a Rust backend project would look like that's less new and less ambitious than Pavex, and that uses sort of standard crates for the various aspects of the project, and also one that is a bit more optimized for the use case we see for backend projects written in Rust. Is the microphone still working? It sounds okay. And that is what we call Gerust. It's our idea for how like a Rust backend sort of project would be structured, that uses sort of standard crates already available in the ecosystem and sort of assembles them sort of in a very particular way, right? It is based on Axum and SQLX. we could have used Actix here, and there's really no right or wrong answer whether Axum or Actix, they're both great. What speaks for Axum maybe is that it's sort of part of the Tokyo project, which might be a positive signal for like long-term sustainability and maintenance. SQLX is relatively easy to use and is pretty stable, and we specifically, or we deliberately decided against using an object relational mapper, as that typically introduces a lot of accidental complexity into a project again, right? So we would rather have a bit more lines of code that are simpler than having fewer lines of code, but having a ton of additional complexity added to the project. One important aspect of Gerust also is that it is not a framework. It's a project generator and maintenance tool, right? But there's no runtime dependency on Gerust. So all of the code that it generates sort of remains under your control without any additional sort of dependencies on any parts of Gerust. Obviously, you have dependencies on Axum and SQLX and so on, but you have dependencies that are pretty established in the ecosystem already, and that you're more likely to trust, right? Because all of you should maybe not trust a framework that I'm announcing here that's like 0.0 point something, right? And not production ready. So that might change in the future, but for now, sort of it's purely something that generates code that you maintain versus something sort of that you're locked into, essentially. Still, while being a project generator, it handles a bunch of sort of the accidental complexity of Rust backend projects, so you don't have to, as I said before, right? For example, it structures projects into separate crates with separate concerns using Cargo Workspace. It establishes a clear folder structure that makes very clear sort of what goes where. And it comes with generators that create sort of elements of a project, like a controller, an entity, and so on, right? And I think while folder structure seems relatively trivial, I think the importance of it is easy to underestimate, because having a clear folder structure where it's really clear what goes where makes it much easier for new people to join and contribute to a project. And it also helps with long-term maintenance, because it avoids a situation where you have a huge mess of stuff and you can never figure out what's where, right? While we decided against an object relational mapper, as I said before, sort of we still suggest sort of a set of standard patterns for the data layer. And Gerust comes with a mechanism for testing your application that makes sure that all tests are separate from each other, while still sort of ensuring simplicity when writing tests and maximum performance. So I hope all of that sounds nice, but words like only go so far. Now it's time for a demo, right? And the demo is going to be, we will be building a really simple task management app with a REST interface, right? The classic example. And now I need to figure out my screen sharing. Okay, great, that works. So we will start by generating a new project, and I think we call that Gerust Hamburg demo. And I just need to bring up my notes here. Great. So we generate a new project, and it's generating. And this is what we have. Takes a second. So we have a new project. Is it large enough, or shall I make it larger? Okay, great. So we do have a new project. Like I said, it's a workspace. We have a bunch of crates like CLI, config, DB, web macros, and the default project is the web project. So let's go through them one by one. First of all, the web. We have like web source, sort of standard cargo folder structure. The lib file is sort of the main file of the project, where in the run function we read the environment, we read the configuration, we set up the application state, we set up the routes, and then we start the server essentially, right? The application state is in state RS, like not surprisingly, and it defines the app state, which so by default has the database pool, like the connection to the database we want to use. The routes file defines the application's routes. Here we don't have any routes yet, but so we'll be adding some later on. And then we have a controllers directory that is empty for now, and we have a middlewares directory that's also empty for now, but that's obviously where controllers and middlewares go. Then we have the DB crate with entities folder. We don't have any entities yet, but that's where the entity definitions and related code is going to go later. We have test helpers. We are not going into detail around those, but we have documentation for them. And then we have a migrations folder where the migrations are going to go, obviously, right? Then the next thing is the config crate, which contains the struct that keeps our application configuration. As you see, it contains database configuration, which is basically sort of the database URL, right? Use this database, and and server configuration is basically what interface to bind to, right? And then we have environments folders, or we have an app toml, and then environment-specific files where sort of you can override sort of settings in the app toml sort of based on the current environment you're in. It's also empty by default, but you would be adding your own stuff there. Then let me close some things. Then we have the CLI crate. So this is essentially the generator that I talked about before, right? That allows you to generate, for example, new controllers, new entities, new entity test helpers. We're not going into detail what those are here because it would be a bit too long, new middlewares and so on, right? And this is part of the project because, as I said before, we don't want Rust to be a dependency. We just want Rust for now, at least to purely be a project generator, right? So all of the code that you need to sort of run and maintain your project is part of the repository. And so are the blueprints for the controllers and so on, right? And then we have the DB binary. Yeah, we're not looking into the code here, but the DB binary is essentially for running migrations and setting up databases and so on. Right, and now I want to briefly remove this again and clone an example that I made before, which is essentially what I just showed you with a few fixes that I made, and we're not going into detail what the fixes are. So one thing that Gerust created out of the box as well is a Docker configuration with a development and test database. So the first thing that we want to do is we want to start up the containers. So we have that running in the background. Let's open a new tab here. And then when we want to write a task management application, the first thing that we need, of course, is a task entity, right? That represents the tasks. So we can generate that with the generator that I showed before. First of all, let's sorry, it's not Gerust. That's so the this is a binary in the application. So we're not using Gerust. We're using Cargo, obviously, right? So we can see what the available things that we can generate are after it has compiled for the first time, of course, which is going to take a second, and then it's going to show us what we can generate. Almost done. Right. So here we see we can generate a middleware, controller, controller test, migration, entity, and so on, right? Like a bunch of things. But now we want to create an entity. Can't generate entity task. And that's gonna create an entity task. So obviously, because of the folder structure, let me close the other things here. Obviously, the entity was created in source entities because that's obviously where the entities go, right? Right, and I'm sorry, this is a bit annoying because Rust Analyzer is, I don't know, doing some stuff that doesn't quite work. But this is sort of an entity sort of that's already sort of pre-populated with kind of example data, right? We have the entity struct here, right? It's like a standard Rust struct with an ID or with a UUID ID and a name, but we want to use a description here, right? Then the next thing that it generated is a change set. So the data layer in Gerust is inspired, I want to say, by Ecto from Elixir. I don't know whether you guys know that. That's yeah, sort of Elixir's ORM, but it's not really active model like, it's a bit different. And they work with change sets where sort of the change set is a thing that, for example, you're validating and then you're passing to a create function, for example, right? And then sort of if it's valid, sort of it's going to be like used to read the data from, pass to the database, and then it's going to return an entity. In our case, there would be a task struct, right? So we need to be changing name to description here as well. And we want to change the faker to this, just so it's nice. And I also need to change this. We don't need to go into detail why I do this now, but the change set sort of come pre-configured at least when the test helpers feature flag is sort of on, which is going to be the case when we run the tests in the web crate later on. So if that is on, we sort of use the fake crate here to make it so that you can easily create dummy data for the tests, right? And this essentially just means when faking a task change set for the description, use a sentence between 3 and 8 words, right? And that's going to be realistic test data then. Let me see my notes here so I don't forget anything. Right, so the next thing that we can do is we can remove all of the to-dos here, because we actually want to use all of these functions. Let me do this. So we do it a bit faster. Whoops. Right, and then we want to replace name with description. Did I type that correct? Description. It's one of the words that are really hard to type. So let's replace all the name with description. So right, so the second thing that we see about the data access pattern here is that instead of an ORM, sort of we said, okay, we would rather have a bunch of simple or a bunch of more simple lines of code or simple functions than an object relational mapper, right? So we have a load all, a load by ID function. We have a create function which takes a change set. Like I said before, it validates that. If it's valid, it inserts a record into the database and then returns a task, right? With the data from the change set applied to the task, and the ID is auto-generated by the database, and so on, right? So we always have these sort of standard functions instead of like a magical ORM setup. Right, so now we should be able to build this. So we'll have a few builds during the talk, but I think they should be fast enough to make it bearable for you. Right, so we've built, but it doesn't succeed because of SQLX sort of compile time query checking that we're doing, right? And while the database is running, we have not created the table that we need sort of to back the entity, obviously, right? So the next thing that we do is we generate a migration. And that is created with a timestamp, the migrations are ordered and so on, which is like pretty standard and sort of what other frameworks do as well. And I have prepared the SQL statement so I don't end up making 1,000 typos here and you all wait forever. So we just create a task table with an ID that sort of be there's going to be assigned by the database, right? And then description, voucher, and so on. So now we can use the DB binary to migrate the database. Oh. Let me. So this I have a bunch of other stuff, right? Ignore this. We're gonna reset all this. So we are gonna start the Docker containers again, and now we should be able to migrate the database, right? And now we can build the project, and it should succeed. Right. So now we have a task entity and all of the functions that we need to load tasks and like save tasks to the database and so on, right? And now I want to sort of reset to a known working version, so we don't end up with a bunch of problems, right? So this is sort of the same code that we just saw, right? We have the task entity and the migration and all of the functions that we need. The next thing that we want to do is we want to generate the REST interface to be able to read tasks from the database or like from the application, which reads them from the database, and then we want to see them as JSON via the HTTP, essentially, right? So what do we need for that is we need a controller, obviously, right? So we can cargo generate, and in this case, we want to generate a CRUD controller. So CRUD controller comes with sort of the typical CRUD functions already built in, so we'll just have to customize that a bit. CRUD controller tasks. So there we have our CRUD controller. You see it already created a test for the controller as well, because obviously it's, we want to enforce good practice sort of, and want people to have tests for the controllers that they generate. So let's close the DB crate and look at the web crate. So we have the tasks controller here, and this case we only care about reading all tasks and creating a new one, so we're going to remove all of the other ones, and then we will sort of look at the read all function first, which is going to return all of the tasks that are in the database, right? That's not necessarily a realistic example, because if you have a million tasks, you don't like want to return them all and so on, but for the sake of simplicity, this is fine, right? So we need to remove like the example stuff, and we now have a pretty straightforward function that uses the load all function that we saw in the DB crate. So in the data access layer, it passes the DB pool from the app state, and then some info here, and then it just returns all of the tasks as JSON, right? Pretty straightforward, but still very clear separation of concern. Sort of you have the database stuff in a separate crate, and this is just using an interface to load the tasks, and you could change all of the data loading without having to change the web interface as well, of course. So just making sure I didn't forget anything here. So it's which would prevent this from working. No, this should be fine. So next step is we need to route the function. So we need to use create controllers tasks here, and then we need the routing get, because this is going to be get request obviously, and then we can route tasks to get task load all, right? And just checking my notes again, this should work, but probably I made some mistake somewhere. So we can ignore the warnings here. This is essentially just all about sort of the stuff that we're not using from sort of the pre-generated things. And so what's the issue here? Can I find load? Oh, why can I not find that? Let me just quickly try and figure it out. We have, so I can't find this, right? Ah, right, it's read all. Yes, great, thank you. And now we can curl and get a response. So we're just curling /tasks, and we get a response. Obviously, the database is empty, so we don't get any tasks, but we can put something in the database here. Just present Gerust in Hamburg. Right? Oh, whoops. No, it's there. And then if we call again, then we get our first task. Right? Right. So the next step is obviously we want to have a test for that. And as we saw before, the tests were pre-generated already. So we can go to tests, API tasks, test, and look at sort of what was generated before, right? And what we wanna, I just need to fix something here. You can ignore this again. Like I said, this is not a 1.0 version, right? So we need to fix that. We want to ignore the create tests because we haven't done the creation yet, right? And we will be focusing on the test read all, and we'll delete all other tests because we don't care about them for now. Right, so then we can sort of uncomment this, and this is mostly going to be fine. But we can have a look at what this actually does. So you see, we don't use the standard test macro from Axum or from Tokyo. We use db test, and we get a db test context struct passed into the test, right? That is made possible via the macros crate. So we do have our own test macro here that sort of sets up the application with a database that is sort of specific and unique for that test, and it also sort of makes it so that the function is called with a context object, and the context object has a database connection to the same database, so you can pre-populate the same database that the application is going to be using when you make the request in the test, and then the database is going to be destroyed after the test. right? So that's all built in. So that's one thing where you don't have to figure out the accidental complexity. What we do here is we create a change set. As I said before, we can just use faker because of that automatic fake data setup. So we create a change set, and then we use the create function from the DB create to sort of insert that into the database. We make a request, so we have some convenience functions here on the application that make writing tests easier, and then we can assert we get a positive response, and then we can assert that the task that is being returned is the task that we inserted into the database before, right? Because we're using the same database, and no other test is going to use the same database as well, because it's a database that is unique for that single test. And this should work. We'll see. Bunch of warnings, but like I said, oops, we don't care. Right. And it does not work because the tasks table does not exist, right? We migrated the database, but we migrated the development database. So now we do have to migrate the test database as well, obviously. So cargo db migrate test. That's going to migrate the test database, and now the test should work, right? And we didn't do a lot of stuff, right? We sort of like generated a bunch of code, sort of filled in our sort of specific, like application specific things into the right places, and everything else was sort of handled by Gerust. Right. So now we are going to sort of check a sort of known to be good version. I'm not doing it clean here because then the rebuild takes longer, obviously. I'm just sort of resetting this so to reduce the risk of sort of making mistakes, and then we are blocked during the demo. So this is kind of the same stuff now that we just wrote without any potential mistakes that I just made and we didn't realize. So the last step we want to make here is we want to make it so that you can also create a task via the interface, right? Via the web applications interface. And as we saw before, we do already have the create function in the controller that was created as part of the CRUD creation, right? There were also like read one and delete and update and so on, but we delete them for the sake of simplicity. So this is the create function now. We can sort of uncomment all that because the code as it has been created is already what we need, right? So we do have a function here that receives a change set sort of as JSON data, right? As part of the request payload. We pass the change set into the create function of the DB create that we saw before, which is going to validate the change set, right? If it's valid, it's going to sort of apply it and then return a task. And if that happens, we respond with status 201 and the task, and a JSON representation of the task. Right, the only thing that we need to do still is we need to route that, right? Because we only routed the read all function before, so this is going to be essentially the same. It's also tasks, but it's going to be post in this case and create. And now this should, this should already work. I prepared a call statement here with some test data before. So if we read all the tasks, we get the one that we put into the database manually. Then we can create a task, right? It's just like authorization you can ignore. It's from a different example, actually, where we had a middleware for authorization. So I should have deleted that. But essentially what we're doing, we are posting JSON here, like a description, right? And this should have worked. And we see sort of the task has been created. If we I'm not sure whether this works. If we do this, this is invalid, then it should, right. It responds with 4 to 2 and an error message. The last thing to do now is to make sure we have tests for that, because as I said before, we want to have tests for everything that we're doing, obviously. So we can enable the tests again. So if you're not sure what enabling means by adding this, so if you don't have this attribute, then the test runner will essentially just ignore the functions. It's just functions that mean nothing for the test runner, right? So that's an easy way to sort of skip a test in Rust. We can uncomment all that, and then we can look at what we're doing here, and the standard sort of crust controller test should already be doing what we need here. So we want to test first that sort of an invalid change set sort of leads to a 4 to 2 response, as we just saw on the command line, right? So we pass a change set with an empty description, which is not gonna sort of meet the requirement of sort of the description having to be at least 1 character long, obviously, right? And then we post that and assert that the response is 4 to 2, and the same here with a valid change set. So we just use whatever we get from the faker, and this works as well. And I just see like there's one actual error here which I thought I fixed before, so we need to go here and copy something from a pull request I made earlier today on the train, but somehow did not no, I can't find it, I think. Let's do differently. So this needs to be slightly different. I'm sorry, this is not as it was planned, but this should be here. Right, so we need this. So ignore what I'm doing here. This like should actually be working already, and then we should be able to cargo test. And no, it does not work because I made another mistake. Probably where's that 49. Right, so this is context, right? And this is also a wait unwrap, and this should work. Oh, and this is a reference. And now it actually works, right? So all of that stuff that it just did will, of course, in the next release, it will all be fixed, and you won't have to do any of that yourself, obviously, right? So that is a very quick walkthrough through Gerust. And to close, I have a few remaining slides now. So that's what we just saw, is sort of how you build a very simple sort of CRUD interface to stuff you have in the database in Gerust. And we didn't do a lot of things. We didn't figure out how to sort of isolate tests. We just used sort of what's there. We didn't figure out tracing and where to put stuff and all of that, right? Yet while Gerust covers a bunch of things already, as we saw, and it has support for more stuff that we didn't look into, like entity test helpers and middlewares and so on. Obviously, this is still pretty early, as you just saw in the demo, and there's a bunch of stuff that we still need to be doing, right? So first of all, and that's something that we work on right now, is we need to finish the documentation and the tutorial. The second thing that we need to be doing and that we're working on is we need to figure out the deployment story. At least we should have guidance on on how you deploy in the most common scenarios, the most common environments, which also includes stuff like how do I run migrations in my production environment through deployment and so on. We need to complete the data access layer approach that we have. It's relatively simple, as you saw, but we're missing support for some things that should ideally be handled out of the box in some form. For example, relationships between entities and some kind of pagination, because any read-all function in the data access layer is obviously more or less an anti-pattern. And we need to figure out a solution for background jobs, because you are very likely to have some kind of background jobs in any sort of production environment. After those, we have some ideas for the future already, but this is sort of more long-term. It might be nice to have support for other databases than just Postgres. It might be nice to have some sort of like out-of-the-box open API integration thing, which is going to be pretty helpful for the typical backend project. And ideally, we would like to have some mechanism for upgrading projects sort of as we release new versions of Gerust, right? Because obviously, like right now, sort of you have like you generate your project, and then when we release a new version with a new blueprint, sort of there's no clear way to sort of migrate your code to that, right? But I think we can probably figure out something that is at least makes it easier, right? But still, we're inviting everybody to check out the framework and give us feedback, because we think there is like place in the ecosystem or room in the ecosystem for a framework, or like I said, project generator for now. For a way to build Rust backend sort of that is optimized for developer experience and optimized for long-term maintainability, which is typically, at least the latter is typically a reason why you pick Rust in the first place, without just blindly repeating what we see in other frameworks, right, in other languages. And yeah, we hope that Gerust can be sort of a tool for the community to sort of figure out the solution to those questions together. And that's it already. Thanks. And I don't know how long I talk, but I guess we have some time for questions anyway.
So, any questions? Ah, yeah. Okay.
Why is it not called Gerust?
Because I don't know whether you can have an Ü, like an umlaut in crate names. You can definitely not have an umlaut in GitHub project names, because when I did the very first sort of experimentation for that, I thought I'm writing a REST server in Rust, so I should call it Rust, but that doesn't work on GitHub.
Yeah, I guess so. But it would have been funny, like a German.
It would have been funny, but I mean, this is kind of funny. It's a play, obviously, on Gerust and Rust, right? And I have to say, the idea wasn't mine or ours. It was Florian Gilcher's idea, and he sort of donated the idea to us and allowed us to use it.
Thank you.
Thank you, Marco, for this great talk. And I would like to kind of ask a small two-part question. By the way, new in Rust community, don't shoot me if I say something stupid, okay? So what we see here is something great, which is something like, with lack of better words, something like what other programming languages in their ecosystem already have. And Rust is still not having it, and we are all waiting for this to happen. Yeah. Like Spring for Java, like Laravel for PHP, or I'm not comparing your code here to those guys.
Yeah,
I'm just saying
sure.
like that's the idea, right? To have like this one dependency at the end to rule them all, and then we can just go in our development node, write Rust code, have fun, right? Is this correct? That's the question.
I mean, more or less. I wouldn't say the goal is sort of to have one dependency, one framework to rule them all. I think there can certainly be like 2, 3 options or whatever, right? But sort of you need, if you're a team that, I don't know, is doing Rails now, that's doing Phoenix and Elixir now, any kind of Java framework, whatever, and you want to go to Rust, sort of you need something that you can build on, right? Because, I mean, you don't want to spend a lot of time figuring out these things yourself, or maybe you can't, right? Maybe you're not allowed to, start from the bottom up, right? Because it obviously takes a lot of time and so on. But yeah, I mean, the idea though is to not just copy what other frameworks have, right? The idea is more to look at why do we typically pick Rust in the first place for backend projects, and then let's build a framework that's optimized for these scenarios, right? So for example, we have no way to render HTML because I personally don't think that's a typical use case for Rust. Right? I think Rust is more for, REST APIs, or a microservice that, like gets stuff over HTTP and does things and so on, right? I can't really see the use case for rendering HTML because, I don't know, we are big fans of Svelte and SvelteKit, for example, right? I would probably choose SvelteKit for building a UI, but then behind that, I want to have something that has stability and performance and so on of Rust, right? So, yeah, that's why we did not just copy Rails, for example, right? I think Rails is great, but I think Rails is for a very different use case than the typical use case you would be choosing Rust for.
And that's the second part of my question, exactly.
Okay.
Exactly in this zone we want to stay. So we have Rust on one side, like one extreme is like the perfect case for Rust, like mission critical systems, memory efficient systems where garbage collection is not allowed, right? These kind of systems. So that's like a perfect place for Rust. And then when we go away from there and we go to Ruby and stuff like, and Rails. Sure. So that's the opposite spectrum. So now you're going away, I would say, with this, we're going away a bit from the ideal Rust place. And I would like to know, from your experience at Mainmatter, your clients or your internal things that you built with Rust, what is the technology that you are replacing with this stack that you have built? What is the thing that was a problem and you decided to go to Rust way?
Yeah. I mean, first of all, I would say I don't think we're going away sort of from, using Rust for building super optimized, very stable and so on applications, right? I think any kind of like handcrafted ad hoc framework would probably look pretty similar to this anyway. I think the place for Rust and sort of cloud backend apps and so on is I think you're typically picking it for its performance and stability, obviously, right? For, I don't know, you have sort of a bunch of microservices and some sort of proxy in front of that, right? That sends sort of requests from like the internet sort of to
the gateway, yes.
Right, to like many of the microservices, sort of based on the requests or so. So I think that's a typical use case for us. Or I don't know, a microservice that you have already, but you have massive stability or performance problems, right? That's what you're replacing. I think once you're past that point, sort of these cases are typically sort of the first projects done in Rust in a bigger company, right? Because there you can justify the investment for a team having to learn Rust and a team being potentially a bit slower with Rust for some time compared to like what they used before Java. So I think once you're past that point, sort of you can replace other things as well, right? Where sort of you don't necessarily, or where it would be hard to argue for making an additional investment for us, because the additional investment is going to be smaller and smaller and smaller and smaller. So you're really comparing sort of only the the sort of advantages of Rust versus the advantages of Java, whatever, then you can always say, okay, this is going to be more stable, it's going to be more efficient, it's going to be faster. And I think the long-term maintainability aspect is going to get more relevant and relevant and relevant over time as well, because like, of the strong type system, right? It's just much easier to reason about the Rust code base. And if you're making a mistake, the compiler is going to let you know, obviously, right? So I think right now the use case for us, or the reasons for picking Rust, are mainly sort of solving performance problems, solving stability problems. But over time, sort of, I think we can like, diversify more into other areas as well.
Thank you, Marco.
Sure.
Okay, I think that we should make a short break now. Maybe, 7 minutes. That we start the next talk at 8. So we have some time to pick up some food and drinks and so on. And then we will have the talk by Andreas at about embedded in a few minutes.
Thanks.
Okay. Then I hope everybody's back. At least almost. Yeah. So welcome to the second talk by Andreas. Andreas is working at Otto, but maybe you will introduce yourself a bit soon. And he will talk about Rust on microcontrollers. So yeah, have fun.
I'll do my best. Okay, I think it's prudent to do a little bit of polling. So who knows how to write Rust? That's not bad, right? Okay. Who is pretty sure what a microcontroller is? That's also not bad. Let's see whether we can keep that or not. Yeah, so I'm trying to get you into that topic. I'm not an expert. I'm working at Otto. We don't do microcontrollers here, so it's not like I'm doing this every day. I'm just doing that if I have time, and I usually don't have time. So, on the one hand, on the other hand, it's basically not a walkthrough for any project that you will do. It's more like as introduction, but I will get to that in a second. If you wanna find me on any social, usually I have this icon here. So yeah, that's usually how you spot me. So for a quick agenda, I'm doing an introduction now, probably. Then I'm trying to refine what a microcontroller is, especially what the difference is between a microcontroller and other devices. Then, of course, like you might have guessed, microcontrollers are not as well supported as we saw a Mac before. I have an Intel here. So there is some difference, and it's important to know the difference and the effects. Then we will glass over some interfaces, what you might be doing, or what might be interesting. And at the end, you hopefully have some kind of guidance how you would approach getting into microcontrollers and getting into Rust. What we will not do in comparison to the previous talk is live coding or anything. And I don't think it makes sense in this session here to kind of start coding Rust for microcontrollers, because I mean you need some equipment usually, you need microcontrollers. I don't brought any with me, sorry. So the current plan would be in February-ish at the makerspace that I will link here. We will do a session. So if you're interested into getting into Rust, into microcontrollers, just join the group, and we will then probably January at best, we will add an event, and then you can kind of try to get a place. I don't know. Maybe nobody will wants this, so it's easy, or everybody wants this, then we will have another one. But we'll figure that out. So, who am I? I'm the guy with the mountains here. I'm just a software guy working at backend stuff. I'm a lucky person at Otto, so I don't have to do Java every day. So I'm allowed to do Go every day. So that's pretty good. I've been not most, but half of my professional career I did C++ and C, and I did like it quite a bit. A few years ago, I've fallen a bit out of that love, so I'm now pretty much, or I do find Go pretty good. I do like Rust quite a bit. You see here, I also like Python. We do have a lot of our software running on Kubernetes. We do a little bit of machine learning, infrastructures code. You don't know that, and we all do that. And if I'm not occupied with anything computer related, I do woodworking, and that's a good switch between just typing all day. Why will the workshop probably be as soon as February? Because I'm at FOSDEM. So if you want to meet up, I'm at FOSDEM, and you should too. Yeah, from the expectation level, really, I mean, Rust is a thing where I dabble every once in a while, but it's not like I'm a pro. So take it everything that I say with a grain of salt, of course. And now let's just get straight in. So microcontroller, right? What you have in these boxes here is a microprocessor, and a microcontroller is smaller, okay? Also, usually nowadays, if you have a microprocessor, you have multiple chips. Microcontrollers, that's one chip. So that's just everything that's in here. Usually with a microprocessor, you have a bus. So here I have HDMI on that bus, I have USB on that bus, and I have a gazillion other things on that bus. Usually with microcontrollers, there is no bus. Or if you want a bus, you have to kind of edit yourself. But the raw microcontroller usually doesn't have a bus. That also means, I mean, the components usually would use a bus, so you get less components, you get less capabilities. But of course, that also means, hey, it can be smaller. A microcontroller can be smaller, it can be more power efficient. But yeah, you cannot do everything that we take for granted nowadays. So I'm presenting here. That would be a lot of work to get a microcontroller to the point that I could just present mirror boards. So, now the question is, microcontrollers, that was more like the object view. So why is it of interest to me? So I already told you I'm not a fan of C and C++ anymore, right? What I do like though is having my my devices running on battery, for example. So the more efficient the whole thing is, I'm pretty happy with that. I'm also not doing this full time. So what I do not want is to figure everything out by myself. I just don't have the time, quite frankly. So I really want to have a solution that other people already successfully implemented. I'm totally okay with fixing one or two things, but I'm not fixing everything. And yeah. And I'm violating that at times, but this is not the story. I do. The people that come to my home usually see a lot of wiring, so I love Ethernet, for example. But I can't wire everything. I mean, there's only so much space I can lay a cable in. So Wi-Fi matters. So I really want to have something that I can control over my network and not have a cable attached to it. Like I said, efficiency is somewhere where I'm big at, and I really like for my devices to boot. I mean, it's kind of okay to have a few seconds for the big devices, but if a small device takes more than 3 seconds to boot up, there's something wrong in my opinion. And I'm okay with doing microcontrollers, but I really do not want to do SMD soldering. I mean, I have big hands, and I tried it, and no, it's not for me. So everything which is kind of more not as delicate, let's put it that way. That's fine, but not SMDs, or even lower. That's not working for me. So that's my story, and now if we come to the microcontrollers, does anybody know what an ESP 8266 is? And would you agree it's very cheap? I would think so. So that's the one of the great. I mean, maybe even the best thing about it is it's really cheap. You can buy a gazillion of these, and you don't spend a lot of money. It's a few euros, and then that's it. So usually you buy them in bulk or have them in big packs at home, and it doesn't matter. It's just a cheap microcontroller. So that's for me the one of the first, at least, microcontrollers that I got into contact with and already kind of did a lot of stuff with it. So programmed a little bit and sold it a little bit. And why this chip is important, I can't spoil now, but we'll get to that later on. For completeness sake, I mean, this is an extensor RISC processor. I mean, we can geek out over processor architectures and stuff later on, but I mean, that's just, it's a processor. I mean, one type of processor. Extensor is the instruction code, basically. And it's just different from, let's say, AMD or ARM. And like, it's so cheap, people have used this for gazillion years. That's at least my feeling. So it's really battle tested, and if you go at GitHub, there's a lot of content that you can use and can mostly see, I think, and can use to get your project started, for example. It only has a single core, but that's probably maybe okay for you. So it's not a big microcontroller, but it's for a lot of scenarios it might be okay. And why was it kind of interesting is that there is it's the grandfather, if you will, to the current generation. So currently, what the ESPs, what they would kind of be replacing that with would be the ESP32C3, and that's not as cheap. So you buy you pay more for that. The good thing is that it's pin compatible, so most of the C code, for example, that you find online will be pretty compatible with the old one. So there are all these solutions already in the wild that you can use with this newer chip. You also see this one already has USB-C, at least in some variants. So you don't even have to do an adapter switch or whatever. So you can use it pretty straightforward with your laptop if you want. And that's also the newer generation in general is the ESP32. And here the C3 is a certain variant. Here I have links to all them, and there are different variants. The one surprising thing is probably that they are not running all the same instruction set. So the C and H, for example, are RISC-V microcontrollers, and the S is an extensor. And I mean, you probably remember that this one was extensor 2. So they are kind of different. And that's also where kind of it begins that you really, if you want to do microcontrollers, you really need to know what your hardware is. It's not like I buy my Intel machine and it has the standard peripherals and standard bus and everything's fine, but you really, really have to read through the documentation, really have to kind of get into, hey, what's the instruction set? Which kind of tooling do I need? It gets just a lot more complicated than just doing, just programming what we, or at least I normally do. And from the capability side, it goes from not so much to a lot. So here you have, you do have Wi-Fi, but you have very few pins. You have very few things that you can communicate with. And the further down you get, the more specialized pins and built-in extensions you get, basically. Like I said before, you do not simply choose a microcontroller. I mean, you basically really have to go the other way around. You have to first really think about, okay, what do I want to achieve? And then you can kind of narrow down which parts or which microcontrollers are even in the picture, depending on your what you want to do. Because there's a lot of combinations, and also personally, I don't find a lot of the official documentation very well structured. So at times you really have to go pretty deep into the documentation until you find, oh no, that's not working because there is a shortcoming X, Y, Z. So that's at times it's a little bit annoying. But I mean, if you really want to, you can do that. And but it's a little bit consuming. And here, I mean, I'm kind of biased, and I get to why I'm biased in a second. And I told you about the ESPs, but I mean the Raspberry people. I mean, who doesn't have 5 Raspberries laying around somewhere? There's also the Raspberry microcontroller. There is the SDMs. There's the Atmegas, and these are kind of the usual suspects, if you will. I know we already talked not explicitly about it, but the reason why I'm talking about the ESPs is, of course, because it's compatible with Rust. The same is true for the RPs. STM, I think, I have a link in here, so they also have some compatibility with Rust. At Mega, I'm not so sure. I think I found something, but I don't really know in what kind of quality it is. And probably there's, I don't know, hundreds of microcontrollers probably missing. But that's at least the usual suspects that I know, and they are all getting more and more supported by Rust tooling. If you follow my scenario, you would use the ESPs, of course. So for the ESPs, the state of Rust is as follows. So we already looked into which kind of type of microcontrollers these are. For recap, for example, the ESP32C are the RISC-Vs, and RISC-Vs are officially supported in Nightly. So that was half a year ago. I have not checked again whether this is kind of stable again. I don't know. But that's in the official tool chain. If you are going with the S models, for example, then you have an extensor. Extensor should be landing or has actually landed in LLVM already, but it has not made all the parts yet into the official Rust support. So you still need to install separate tool chaining to kind of cross-compile to the extensor models, the S models. Also, if you really want to go back, or if you would really want to go back, there is no support for the ESP8266. That's not to say that some people are not trying to do it, but I wouldn't kind of keep my hopes up. I mean, people are working on a hardware abstraction, for example, but I mean, this microcontroller is so weak that you really the question really is how much you can do with it anyway, because there's barely anything there. So I don't know. You can try it, but I personally would rather buy an EU chip and get it over with, because yeah, I don't know when support would even be finished. On the other hand, what I neglected to say, I think, is that the ESP8266 is deprecated officially, so they will not make new ones. So the new ones are really what's officially supported. In today's world, somebody will probably try to get Rust running on that thing. I don't know how many years this will take and how stable it will be actually. So far, also, I do have one S at home, and I have not done anything with that really. I've always been kind of lazy, and the risk Vs were good enough, so I never got over the bump of installing the toolkit and everything. So I'm quite okay with the risk V, but it depends on what you want to do. So now the question is, and now we get into the interesting stuff. So if you have the ESP32, for example, then you don't have it because it's pleasing to the eye. Usually what you want to do is you want to program it. I mean, that's what we're here for, I think. And who knows what STD versus no STD is? Okay. So for the people who don't know, STD is the standard library, like the name suggests, I think. And the standard library has a lot. And if you here kind of subtract the standard library, there's not much what's left. I mean, yeah, you can program with that, but what you can do is pretty limited. So, but of course, that's kind of a deliberate choice. I mean, if you have the STD, there's a lot of software and at times an operating system what needs to be present, versus if you have no STD, you don't need anything. You just need to execute the code, and that's everything that you need to get your program started. And that's also a huge problem with Rust, I think, because I mean, in my opinion, it was always pretty straightforward, because if you did C or C++, you were always kind of content with, hey, there is not a lot of library support, hey, you can't do that, hey, there's no support for this, and everybody was kind of happy. With Rust, you nowadays have so much possibility. You can do web development, you can do this, you can do WASM, it supports everything basically, but it also means you're kind of spoiled because you want to do all that. But on the other hand, if you go into the low-level part, then it also means your operating system maybe would not even allow to do that. And that's the point. If you do microcontrollers and you do not have an operating system which supports part of the STD crate, for example, that basically means you cannot use all the shiny basic tool that we have. I'm not even talking about the layers on top, so all the nice libraries we have nowadays. I'm just using the standard library where the most crates, I think, depend upon. But let's say you just have your ISP and you want to get started. So you can get started with both, and I really am quite surprised how good the documentation is there. So it doesn't really matter which route you go, the documentation is really good. If you want to get started with that, I've linked the books here, the book here, and you can just start. And the book will really take you through that. It's well written. There's most of what you will have to know, and that's all fine. Caveat is you should kind of, I think about what you want to do. There's this thing ESP Home where a lot of the stuff that you might want to do with your microcontroller might already be kind of scriptable. So for ESP Home, you have a YAML, for example, and you just configure, hey, I want to read this sensor and write it to the ESP Home supported backend or whatever. And the question really is, I mean, I do like writing Rust code, but is it necessary? So there may be a variant where you just want to read a sensor and you don't need to do all the complete Rust dance, but you can just go the ESP Home route and kind of make your first experiments with microcontrollers this way. Maybe that's easier, just for completeness sake. If you still want to program Rust, then we're still left with these two options. And now you have to choose. Well, with every other microcontrollers, you have to choose as far as I know. And the good thing with ESP32 is they support both. And that's, to my knowledge, really a feature that no other microcontroller yet does. So what they do is they basically, do I have it written here? No, so sorry. So they provide a whole tooling. They provide a free RTOS runs on that. So they have an operating system and they support threading and whatnot. So you can just use your microcontroller like every other device, basically, and just write your Rust code, use your libraries, and be happy. And that's, I mean, a biggie for a software guy who doesn't do that every day. That's a big feature for me. So with if you go the standard edition route, then that basically means most libraries should work. I mean, of course, you will get into problems like RAM. Microcontrollers do not have that much RAM. They do not have that many CPUs and whatnot. So yeah, you need to be kind of careful there. But the libraries itself, they should work. Unless you interact with C. So all the sys libraries and whatnot, it's a fucking nightmare. So you can do that, and I wish you all the best of luck. So I tried that with a few of them, and it's really a pain in the ass because with all the cargo tooling and all that, you kind of forget how difficult it is to interact with the system. And for everybody who has done years and years of C++ and C headers and trying to get everything in the right path with the right defines and whatnot, and you will get there again. And getting kind of the search path, defines, cross compilers just right is just a nightmare. You can do it. Nowadays I'm not so fond of that anymore. So I don't know. I really try to just use stuff that is pure Rust, or at least they have already figured out the headers for the ESPs, and I don't need to worry about that. LowSTD is really the black hole of anything. I mean, yeah, you can do that, but everything STD will not work. So you can kind of try to filter your crates and see how many require STDs. Usually it's 90 something percent something. And you then need to look for, okay, what are explicit NoSTD libraries out there which kind of work. Usually they also have dependencies, so you kind of need to search for the transitive dependencies that work with your microcontroller, and you have the same problem basically. So if you, as soon as you interact with seek, then you need to find all the headers and all the stuff, and it's just horrible. It is possible to do both STD and OSTD, but I mean, you kind of, I mean, you do, you make yourself the. It depends on how complicated you want to make your life. If you have some grandeur ambition, then probably it will be more problematic than if you are kind of content with sending some data to Wi-Fi. That's probably the easier route. If you want to really do crazy stuff, then or normal stuff for desktop, for example, then it might get painful. You will figure it out if you invest probably enough time in there, but just be warned that it might be painful. We already before saw Tok you mentioned. I mean, everybody knows there's async and stuff. If you hear about Embassy is basically the async await, but in the embedded space. And they're getting there. They usually, if you read about their progress, they're doing. They have great progress. I personally do not really know why I would use them, quite frankly, because the whole point for me why you would use an embedded device is, or usually, you have so little RAM and so little CPU that I really do not want anything which runs in parallel and where I do not have control over when it runs and how much CPU I need and everything. That sounds to me a little bit, I don't know, not for me. But I mean, if that's for you, then async await you can do in embedded too, or at least soonish. It's not totally there, but it's quite good. Back what I already talked about. If you use the STD route, you are implicitly interacting with IDF. IDF is what Express calls the IoT development framework. Basically, that's a collection of all components that they need to get the standard library running and more. It's also kind of connecting to components, getting LEDs to work and other stuff. It also means that they are booting not your code, but OS first, and the OS does some handling that you need for the SD crate. But I mean, all that means that STD, which uses IDF, gives you more functions at the cost of more overhead. So, I mean, you need to kind of decide whether this is okay for you. If you have, for example, a ESP32H model, then this has quite a bit of RAM, quite a bit of CPU, so might be fine. Also, I tried this with a C model, and it's also fine-ish to the point where you break the stack or something. But it's kind of, you can use that, and it might, for the people who come from normal desktop or backend programming, that might be the easiest transition into embedded, probably. That's also the SDKs. I have a link here. You can look into all the gazillion different components and all the SDKs that the IDF provides you. It's a pretty good list, and I personally find it really impressive what they are doing, especially on such a small device. And a lot of that is supported on Rust. I mean, if you get the list of IDF features, I would guess 50% of it is supported in Rust, and they are making really great progress. So I think that's pretty fine. So I mean, I gave you now the basic where you would start with. I mean, if you want to step the step guide, basically, I mean, you usually would not really buy a microcontroller itself, but you would buy what's called a dev kit. That's basically a microcontroller with some specific stuff soldered to. So usually, or the good dev kits do have support for plugging it directly via USB into your computer. That's pretty easy, or makes development a lot easier. Yeah, but I mean, like I said, you really have to kind of read into that. Or, and that would be my recommendation, I would kind of recommend talking just to guys who do or have done embedded programming before. I think that's probably less time consuming than trying to figure out that yourself. I did that, and it is quite a bit of reading. Let's put it that way. Yeah, so buying a dev kit, you can do that. I have faith in you, so that's okay. Installing Rust, or everybody installed Rust at some point, I think. So it's pretty straightforward. Like I said, if you go with the extensor, you need to do some special steps for the tooling for the extensor. But aside from that, I think that you will manage. Also, the books, just good documentation, read through them, follow them. It should work out basically. And at least for the ESPs, they do have a metrics. Is it metrics? I think it's metrics. They have a metrics channel where you can ask questions and they help you. And it's I'm not paid by ESP, curiously, but they're really doing a great job. Yeah. So if you have done all that, then one of the things that the training book will tell you, and I think it's pretty great, is that you can pimp your cargo. So one of the things I really like about Rust is that you can extend cargo, and you can, for example, here extend cargo that you do a flashing. So you do not just run it, but you also flash it on the microcontroller and immediately run it. So it's just one command, and then it takes all your code, runs it on the microcontroller, boots it up, and you can test it. So and it connects to the logs and everything, and that's really nice. One thing that they also will tell you is please do not set up your own projects. I'm bad at reading advice, so I did it anyway. And it usually doesn't work. It's really, you have to have the correct combination of Rust crates, because the official symbols might match, but still some detail will not match, and then it will not work. So you really should, like for the other project, should rather generate the project and have the correct combination of crates that are proved to have worked in the past, and yeah, shoot yourself not in the foot trying to kind of figure out why something doesn't work. At times it just compiles and just doesn't work. So that's even the worst one. If you, I mean, you can use the ESP flash. That works great. At times, you might, for example, drive to your favorite Eurorust or wherever you just usually go, and you do not always want to carry all your microcontrollers with you, and they are kind of delicate, so you don't want to kind of damage them. There are simulations for that. So there's this company or product, I don't know, Wokwi. They kind of provide you with an ESP32 emulation. Yeah, I think the correct word is simulation, sorry. And that works surprisingly well. I mean, I kind of tried it out. The docs are okay-ish, but you can ask them questions actually, so they answer on your questions quite okay. And for the most part, it works. I just encountered 1 or 2 bugs, and then it was just easier than doing the microcontrolling. I also didn't travel that much at that time, so wasn't the thing where I really needed the simulator. But might not be a bad thing to have that. So if you kind of are curious, I would just check that out. Also, that probably then means, for example, if you do not want to buy an ESP32H, I think they are a little bit more costly, at least a few euros, maybe. Then you can try the simulator first, see, hey, is it maybe okay? Does it sound right, what it does? And then you can still figure it out. So can recommend that. Yeah, and that's basically where I'm ending up with the scenario where I originally tried to use Rust with. So my idea was I need a microcontroller because I want to have my kind of nodes that I usually have in Google Keep, and I do not want to have to reach into another device. I want to have an e-paper which displays all the to-dos that are still open somewhere in my apartment, for example. And of course, you can do that with Raspberry, for example, but that would mean that Raspberry would have powered on every time, or at least you would have to start it at certain times. And I would thought, well, I will do that with a microcontroller and perhaps even have a button. So yeah. And the red thingy, of course, means that I still don't have a button on that. I do have a prototype where I can kind of load tasks and kind of displays the whole thing on the e-paper. Like said here, it's still not doing it at 6 or something. It just it never got beyond the prototype stage, basically. Where did my slide go? Here. Okay. So just to give you a kind of thingy how that looks usually. So what you have here is, for example, the microcontroller, inverted, of course. Here you connect the pins. Here you have the USB, so that's power basically, and control, where I then flash the program. And I mean, that's nothing new for people who have already done it, but here you have the connecting. Then the cables go all the way to the driver. So that's the driver board basically, who drives or who kind of does the communication with the e-paper. So kind of does the protocol. Yeah, you have to kind of figure out what the protocol is, but there are libraries for that. And I do not have a great experience with a lot of manufacturers. I do have some of the e-papers from Waveshare, and they are pretty okay. The Rust support is kind of good, and yeah, that's just what I tried out and can recommend. So if you want to give it a try, at least I think there's nothing standing against Waveshare e-papers, I think. Then you kind of have the connecting here, and then you have the display connector, and then, for example, if you do that, then you have the e-paper, and then you say hello Rust, and then you kind of moved all the data to there. Then you can already, I mean, these are pixels basically, then you can display anything that you want on that device. Yeah, that's basically this is not bragging rights or anything, but it's at least yeah, how you can expect that to go. And you still then have to do additional tasks. I mean, that's not like having a chassis like here, but still have to kind of do housing and kind of trying to solder all that. So be aware that the real work goes beyond just programming the device or the microcontroller. Now, if we come to a few challenges, I cut it down a little bit. I mean, you already can imagine, since we do not have that much RAM, then we only have a limited stack. Also, if you, for example, try to allocate something on the stack which doesn't fit on the stack, that will just mean that your device is restarting. So it's not like it will tell you, hey, you used too much. No, it just restarts. And you have a few of these idiosyncrasies where you, as I don't know, an abstract programmer would expect your OS to kind of tell you, hey, you are doing something wrong. No, it will not tell you anything wrong. It will just go. It will not go up in flames probably, but it will do something, and you will not at first figure out why is it doing that. And then you really need to look at your code and see and try to figure out what it's doing, which is also kind of problematic because in Rust there's also a tendency to kind of abstract stuff a little bit too much, in my opinion. And at times it really means that you have to go into the Rust code because it's so generic and so blah. And you kind of have to figure out which kind of memory it is allocating implicitly, where are the boxes and where not, and where is it using the stack and what. So I mean, it's doable, but it's a little bit yeah, it's a little bit cumbersome at times. Let's put it that way. One thing that you really should look out for, at least if you want to do development, is that the protocol for talking to the microcontroller over USB is using usually the UART. And you really need to be careful to choose a chip where you can use UART and you can use other pins also. So if the other pins, or if the UART pins are used to, for example, drive LEDs, and you want to drive LEDs, then you cannot program your thingy anymore. So you really have to kind of be mindful about, okay, I need to have, for example, a dev kit with distinct UART pins, and then I need also some other pins which can, for example, drive LEDs. And there's just a kind of little bit consideration with where you kind of need to think about that before buying, hopefully. Or you buy just one or two and try to figure it out. Then I mean, you have a whole lot of kind of protocols that you can use. These are usually wire protocols. So here you have something for getting LEDs to kind of light up and work. Here is more general faster communication. To see is kind of not great, but not bad, I would say. And one wire I don't really like, but it's kind of yeah, for really simple stuff it may be okay. So still, we will not do the live coding here. I would just try to give you some kind of idea how it might look like, and I mean, that's nothing new. We have a gazillion users. You're all familiar with that. Then there's, for example, if you use IDF, then there's some patches that you need to be done. So you know you do it all that pretty deep in the system. You do a logger initialization. That's also not so interesting. Here it gets interesting because if you, for example, I have a display. If you allocate the display on the stack, it will blow your stack probably. So you are not allowed to do that on the stack, but you need to box that whole thing. So all these things you kind of need to learn. And that's where it's a little bit cumbersome, because you kind of need to figure out, okay, is it doing it on the implicitly on the box, using box inside of the display? Some libraries are, some aren't, and kind of you need to dig into the source code at times, and that's the annoying part. Aside from that, if you have done anything with C, then probably that's pretty nice, because here you can just define, for example, that the GPIO 14 I want to use as an output pin, and use into, and it does all the crap for you. Doing that in C, can remember that it's a little bit more cumbersome to kind of get it to be an output pin. And the rest is pretty simple, just straight up Rust code. I mean, there's what you would do anywhere. You just really need to be mindful. You need to configure it with the correct baud rate, the correct config for SPI communication. There's just a lot of you need to get right. If you get it wrong, it's just not working. It might not give you any hints why it's not working. It's just not working, period. For drivers, yeah, what I built here is just an example where you, for example, depending on whether you have an anode or a cathode LED, you need to kind of reverse the thingies, so the values. Yeah, that's just basic interaction with the pins on this whole thing. I mean, it's a little bit interesting here if you come to the clock cycle. But basically, most of that it's kind of documented, and the rest, if it's not documented, you kind of have to figure it out and kind of try to figure which kind of parameters your device has and how you need to interact with that. But yeah, I mean that's probably what's kind of normal, or what you would expect for embedded programming. Yeah, so with IDF,
Maybe I just repeat the question. So where does the logging go?
Yeah, the logging. I haven't run an example with no STD. I can just tell that the STD variant via IDF is streaming the logging over UART to your console. So that's pretty nice. I do not know whether this is working with no STD.
So yeah, this is also working for no STD.
Oh,
Same
that's
thing,
nice.
I think.
That's very nice. So yeah, but that's basically most of my rambling, I think. And now, if you already started it, questions, feedback, now's the time.
Thank you, Andreas, for presentation. I have a question related to your playing with C code and embedding it. Any existing tools to simplify this task? Have you seen, or it's not exist?
I mean, with regards to interfacing Rust with C, you mean? There are some tools out there where they use the symbols and generate the Rust code for that, or they try. But the result, I mean, I think the problem is there are no standards in C. Everybody does everything, basically. So I think I found some tools that do something and generate some headers, but the manual cleanup afterwards is probably as bad as writing it from hand. So I don't know. It didn't help me. Also, for the most part, it's the problem of getting all the paths right and the paths in a format or at times split even, so that the bindings kind of like that. At times, if you have I had a lot of fun with Ubuntu because with Debian packages, it's at times different what the original maintainer would have done. So that's one of the reasons why I nowadays switch to Fedora, because it's less fucked up and it's probably easier to do the development on Fedora, where everything is not as mangled as it is in Debian, for example. At least that's my hope, because with Ubuntu I had a lot of problems on the system side, because it just diverges way too much from what the upstream usually uses for headers and how they are packaged, how they are structured, and so forth.
You're talking only about operational system interaction. What about nested legacy code written in C, for example? And what is your recommendation which step we should do to migrate from C to Rust? Initial idea is to embed it or wrap or extend with Rust.
Yeah, I think it does really depend on the ownership model that you have in the C code. I mean, Rust has very strict rules about ownership. So usually C code has everything. I mean, there are a lot of libraries who just do it somehow, and you have to figure out what the ownership model basically is. So my first instinct probably would be not to try to get a large C code base, for example, to Rust, but to kind of interface it and kind of try to make it work. But I mean, that probably also just works to a certain extent, or to the extent where you have to kind of think about, okay, how much state is living in the C code, how much state is actually, do I need to transfer objects? Is it okay to copy them? Do I need to reference them? I think there's a gazillion kind of stuff that you need to take into account. So I don't think there's one fits all advice for that. My experience, at least.
Thank you for answer.
Thanks for the talk. One quick comment on Embassy. I think you've mostly presented it as Tokyo. as a Tokyo alternative, which usually Tokyo sits on top of the operating system. Right? An embassy aims to be the operating system, and hence tries to replace, for example, free authors. Why? And now you said why would you do async on an embedded controller? And they claim instead of doing what free authors does, which has like threads and then it has like an interrupt controller to preempt these threads and then switch between threads back and forth, they use the async model, which is basically coroutines, which allows them to switch between different tasks. And hence, it's a different model. It's like a cooperative scheduling, right? Because the coroutine has to willingly schedule back to the operating system. But if you do that regularly, I've heard claims that they're more efficient. They have like less overhead than what free authors does. It's basically a smaller hammer, and in certain scenarios, it actually works quite well.
I can believe that. I still don't know whether I think the embedded space is quite big. So in the stuff that I usually do, I probably would not want to use any async stuff. I really want to kind of have the control of, hey, that memory is just allocated now here, and if I need to be cautious about memory, I just deallocate it and move it, I don't know, somewhere else or whatnot. So for me, it would be more mental strain probably also. But I think I'm not doing that day to day. So perhaps if I would be more doing that more often and more familiar, maybe that would be fine. It's just for the guy who does it every once in a while. It's kind of like no, I don't like that complexity.
Yeah, I think it also depends what you're doing, right, with your microcontroller. Yeah. As for example, the example you've just shown with the display, right? Like you're basically fully in control what's happening when. But for example, if you have, I don't know, an running MQTT connection or like a stream to a music system or an audio system, where you basically in regular intervals need to react to like inputs, because otherwise the client might think you're dead and like breaks the connection. And then you have like very quickly like multiple things going on at the same time. Then it gets like really nasty about like if you don't have threading or like any kind of like multi-task scheduling going on, it's like really hairy to do that.
Yeah. On the other hand, the question always is maybe you even would like to have more than one microcontroller in this scenario. One for handling the MQTT and stuff, and one for doing something else. But yeah, I get what you mean.
Any more questions?
Some time ago, I played with STM32, and when I got off the very simple blinking the LEDs path, things became very difficult, and HALs became very, shall we say, interesting and difficult to initialize. Particularly initializing on STM32 proved painful. I haven't looked into this area for about 2 or 3 years. Have things changed in terms of the documentation and support much in your experience and of the experience of the audience?
For me, I only have experience with ESP32, so yes and no. So the documentation is good. I mean, I'm one of the guys who is really kind of happy if there's documentation at all. I mean, we all kind of are probably rather coding than documenting usually. So that's, from that perspective, pretty great. But it also kind of depends on how much value there is, I think. So I know that the Express guys have dedicated developers assigned for Rust, for example. So they can probably do some more progress than if you have some open source guy who does it in his 9th hour of work or something. So I really can't speak to other devices really, and you need kind of to really read a lot of documentation, because not all values are kind of easily accessible. That's what I found at least. But on the other hand, at least for me, if you do not have a deadline and you kind of have all the time in the world, so that's okay, because I can didn't find it today. Okay, I'll search tomorrow. Who cares? If I would have a deadline behind that, then it would probably get a little bit more annoying to search for parameters and find why certain stuff doesn't work. But probably not answering the question.
Okay, then, yeah. Thank you, Andreas, for your talk. Also, thank you, Marco, for your talk. And if you like, there's still some time left for socializing, and there's some food left and some giveaways from Otto. So, yeah, help yourself and have some more fun.
And all the food needs to be eaten.
Yeah.
Thanks.